Okay, thanks for joining. I think we've waited just about 2 minutes now, so we'll get started. So the agenda for today, we're going to be covering AT commands. So first of all, my name is Brian Smith. I'm technical writer at Emnify. I've been working here for just over a year now, just recently celebrated 1 year. And the last couple of months, I've been working a lot with some development boards where we use some modems for testing here at Emnify Sims. So over the couple of months, I've been learning a lot about how to use AT commands. And so this webinar today will be covering basics of AT commands. We'll be getting straight into some demonstrations. I'll be covering some of the common or standard commands, some tips, possibly pitfalls, and then at the very end, we'll have a bit of time to cover some questions that any of you have. So first of all, if you have any questions during the webinar, you can of course use this questions panel. Here you can post them directly at any time, and my colleague Jean-Oud will do his best to answer that. But of course, we'll have QA at the end. And if you have any problems with audio or video, you can please let us know there. Okay, so what are AT commands? So it's basically a short text command language, and they've been around for quite a long time. So they were first developed by Hayes, which was a company producing modems in the 80s. So they date back to about 1981. So they're around nearly 40 years now. They were used extensively in dial-up modems in the 90s, and manufacturers would commonly take these and implement their own commands if they had functionality that they wanted to support for their own hardware. So this is important to know because there's no strict set, standard set. So quite often manufacturers will add proprietary commands. So they're used quite commonly today for controlling quite a lot of different kinds of modems. So how does it work? Basically, you have a laptop, a computer, a host, or some kind of microcontroller, and it sends the command over USB or serial to the modem itself. So the modem might not necessarily be an external device over USB, but this could also be integrated. So the modem is soldered inside the device and the host communicates internally via AT. So it can be a lot of the time that the AT commands themselves are hidden away and you don't really see that they're happening, but they're being used in the background. Often GUIs or something will hide that. So for the demo today, I'm using a Raspberry Pi. So these are quite cheap. They range from about 15 to 35 euro. And the great thing about these is that you can run Linux tooling on them, which means there's a lot of different options for languages. There's a lot of standard libraries that you can use that come straight out of the box or that you can install. So it's very easy to get started and they're very flexible. So of course, we're going to be using an Emnify SIM for cellular connectivity. And we have the 6Fab cellular IoT board. So this is about 60 euro. And the modem that we have is BG96. And this is one of the most popular modems on the platform. So there's a lot of certifications that it has. It can operate on a lot of different bands, which makes it very good for roaming internationally. So basically, you can see on the picture in the bottom left, we're using the serial pins on the Raspberry Pi to send commands to the modem. So on some development boards, you might send this over a USB cable, but in this case, the nice thing about the Raspberry Pi is you can also treat this as a USB port. So in the software side, we're using Screen, which is also a very old Linux utility that turns out to be very flexible. Very, very simple, but it's perfect for this use case. 6Fab, who are the makers of this development board, they also produced a Python library So this is essentially like a wrapper for their AT commands. But really, you can use any language that supports serial communication or GPIO. It's very basic. All you're doing is sending a command and waiting for the response. So you could do this in Python or Ruby or whatever kind of language that you like. So for the demo setup, I'm SSHing from my computer to the Raspberry Pi. I'm using screen to send some AT commands to the modem, and then the modem is responding. So let me just bring up a terminal for you. Okay. So at the moment, now I have a session on the Raspberry Pi itself. And this allows us to use the screen utility. And what we'll do is we're using this TTY-S0 port. That's standard with all of the 6FAB ports. So this would be the same if you have the same setup. And the last number there is the baud rate of the modem. That's also the same. And it's very underwhelming, but this is actually the session. So I can start sending AT commands directly to the modem now. And you can see that the very basic response to show that the modem is actually responding is okay. So here's some of the standard commands. What you would likely do, and maybe you notice here, is that I'm using lowercase here. In most commands, it doesn't really matter, but you might find that it's best to stick to uppercase all of the time. In a lot of these standard commands, it doesn't matter, but it's probably best practice to stick to uppercase. So if I type ATI, I can get the information about the modem itself. So, oops. Then we have ATC pin. This is to check the SIM status. Okay, so this is one of the first stumbling blocks that you might hit. So here we have an error with a command that we've just entered. So it's, unless you have the spec handy, it's very difficult to know exactly what that means. So one tip is to use this CMEE. And this is like an extended error reporting. So once you set this error reporting to 2, this means that it will add some additional information. Oops. Okay. Okay, so we get a proper error message that the SIM is not inserted, and that's actually true here. So just for the sake of the demo, I started up the development board without the SIM. So this verbose error reporting helps with actually diagnosing what the problem is here. So after putting the SIM card back in, what I can do is restart the modem. And we get the response, okay, that the device has received the command, it's powering down, and then we get ready back, indicating that the modem is in fact ready to communicate. So again, I can send the C pin, and we can see with the response we get here is that the SIM is ready. So this is the basic flow that someone would use to interact with a modem. So I'll just get rid of the terminal window. We'll bring that back up again. So this is the general structure that commands have. The equal sign in the middle there indicates that it's a write command. Then you have a couple of parameters there. The first one is the context ID. The second one is the PDP type. The last one is an APN. So this is a very common command that we would use, and also a very useful one. And this is to set the APN for a PDP context. In this case, we're using EM for Emnify SIMs. So, of course, you have to check the specifications, which parameters are expected, what the meanings of them are, and what the expected responses are. But this is the general, I would say, convention for how to read and write these commands. So typically there's 4 categories of commands. The first one is to check what parameter values you've set. So this is usually after you've set them via write command. You have a read command, which is tell me what the current modem state is. And then you have the write command, which is linked to the first one there to write some parameters to the modem. And then, of course, to execute. There's some examples. So the first one would be to check what bands am I using. So the modem can, of course, use plenty of different bands. This will tell you what the current configuration. This is more like user configuration. CREG, the second one is what's the device state? Is it registered to a network? The third example there is to set the GSM band to 900 megahertz. So this string of zeros and the 1 just after band, this value you find in the Quectel spec. So they have 4 or 5 different values that you would use to set the different frequencies for the GSM band. And then, of course, ATI at the end to display the product's identification. So other than that, what else can you do? Well, you can wake or sleep the device. You can read, send SMS. You can get location information. You can scan for available networks. You can register to specific networks using a certain RAT type. You can create PDP contexts, send data, get general hardware information, and it's quite a lot more. So we can continue on with some demos. We can see how it works to set the bands on the modem, try and register to a network. That's one of the first steps, and for that, of course, we need the terminal session again. Okay. So just for convenience, I've copied across this command. So the first one that you can see on the top there, that's particular values that you'll find in the modem spec. So F means any. So this is for the GSM band, the CAT-M band, and the narrowband frequencies. So this command basically tells the modem to use any band that it likes to connect using these technologies. So I can check using COPS. This is a common command to check what the network registration status is, and 0 is the response code for, well, I'm not currently registered to a network. So it's possible to manually register to a network using this. So we use, in this case, the numeric operator code. And this is the command to register to Telefonica O2 using CAT-M. So if we check here what the network registration status is, using CREG, 05 is the response code, meaning that we are now roaming on this network. And if we run this AT-COPS command again, you'll see where before we had 0, now we have 1, meaning the network is available, the numeric operator code, which is the country code and the operator number, and then the 8 at the very end, that's the radio access technology. So that means I'm connected on CAT-M. So this is useful for seeing what the device state is, and to maybe say, okay, I want to set the modem into an automatic mode where it will connect to whatever network it finds and is able to register to, or I can manually force the device to try and register to a network that I like. So because the response codes are not very verbose, you just get numbers, 1, 2, and then 8 at the end. It's necessary to look up the specification and see what these values mean. Okay, so what else can we do while we're still registered on CAT-M on Telefonica? Well, one very common command is to check the signal quality. So this, I believe, is decibels. So this goes from 99 down to 0, and 0 meaning the best network quality. I think anything above 30 means that it's bad. So 26 is fine, it's fair. Anything I think below 15 would mean you're standing right underneath the cell tower. So this means that I have a reasonable signal quality here. And you can get some further network info using Q network info. And so this will tell me at the moment, okay, I'm using CAT-M1 as a radio access technology. This is the mobile network, the operator code, the band number, and I believe the last one is a cell ID. But this is also very useful because, okay, if you wanted to fine tune later on that I only want to use a certain band within Germany, let's say, or within Berlin, I would just restrict these devices to use band 20. Why would you do that? Because it's a lot quicker to associate or register with that network if you have just using the bands that you know you have to. Okay, so PDP context. So I believe we already have one active here, but of course we can check. So this command here checks what the status of the PDP context is. I've already defined one. So you can define many. One means is the ID, and we're using IP type. At the moment, we haven't set an APN, but we can do that, of course. This is one very common configuration that we would do, is to set the, oops, I have some strange characters in there, is to set the APN to EM. Okay, so this is the command that we saw earlier on in our demonstration, where we showed we have different parameter types. So the first one there is the first PDP context. It's an IP type, and the third parameter is the APN. So this is a very common AT command that people have to use. It's very common with all kinds of modems, including GPS trackers. So this would be a very useful and very common one. So we can also check the status. This CG act is to query whether it's active or not, one being yes. The first one is the ID, one is it's active, 0 is inactive. And with this, we can verify this using a ping command. Oops. So the syntax there is ping using the PDP context 1, and then the server address that you want to ping. In this case, we're using Mnify. Oops, we have an error. Okay. So what we have now is, by default, it'll start 4 pings. of whatever server. That can be an IP address or host name. And we should get some kind of a response from this now. If not, we can also try this again. Yes, so it's waiting for some input from me there. Okay, so we've just sent 4 pings to Emnify, and it's resolved to this IP. The response there at the very end, I would have to check the spec, but it's basically told me that it sent 4 pings. 4 were successful, 0 were unsuccessful, and I think these last 3 digits are the average timings. So this is a good check to see, is my connectivity working or not? Probably a very standard if you were to be running some connectivity tests. Another feature, of course, that we can do is to check SMSs. So we use this CMGL. Oops. I see. So the problem that I have here is that I haven't set the modem to use text mode. So there's a few ways of handling SMSs. And the second command that I have in this example is to say, okay, I want to also, instead of having all, we have a numeric equivalent to that. So, okay, this lists all text messages at the moment. So there is none, we see there's one, sorry. This test SMS I just sent earlier to the device, it's with 0. That's the first in the index. It's been read. And this was the send time test message. That's the content of the message. And actually, this one good exercise that we can do now is to take a look on the Emnify platform. So we can see here earlier on, I've sent an SMS to the device. We can do this again. And we can see if we can view. So we get a delivery receipt from our platform showing that a few seconds ago we've submitted an SMS. And we can try this command again and see if we get any different response. Okay, so you see 0 is the first index, the one from earlier on, and then the 1 is the second SMS, and it's unread, and we see demo text. So this is a very low-level example of how you would read SMS from the device. Of course, it's also possible to send SMSs. But I think we can skip over that. This operates in the same principle. There's one thing to note is that it expects a control Z, which is there's a special character that you need to end your messages here. But this is very basic, and this is also very well documented of how to send SMSs using AT commands. So what are some other interesting commands? Okay, well, EasyX is a very new technology that a lot of modems and networks are just starting to support. And this is a type of power save mode where the device will go into like a sleep mode for a specific time period. You would negotiate with the network that the device would be awake for a certain amount of time before going asleep for a specified time limit. So there's a couple of factors that need to be that need to be in place for this to work. Firstly, the modem has to support it. The network also has to support it, but also the cell tower. And it's possible to send an AT command which checks if the network actually supports this. So unfortunately, where we are right now, we get a 0. So this means this cell is not the currently registered cell doesn't support EDRX. But this might be if you're developing a test suite or something for your devices, if they're roaming around and if you want to test EDRX, this might be a very good one to have to see what does the actual infrastructure support. Okay, if a network might support it, but can I use this extended power saving mode in certain specific geographic areas? Okay, some other tips are that you want to have network registration verbose mode. There's a few AT commands that will really speed up uh, a lot of your development. The first one I covered earlier, which is this extended error response mode, but also this for registration, setting this mode to 2 also gives you additional network registration info, so you'll get more detailed reports of why you can't connect to certain networks. Also, this Q signal quality, this will tell you very detailed signal information. So I'd have to look up the spec for this exactly, but it's a lot of signal to noise ratio values. So something very technical about what the signal quality is of the device in that area. One thing to note about the commands that start with Q is, like I mentioned in the first slide, about a lot of manufacturers adding their own AT commands that have proprietary functionality. With a lot of the Quectel commands, you'll see this Q as a prefix, meaning this is a Quectel only command, or it's been implemented especially for Quectel modems. And this detailed signal info is one of those. So this is not something that you would use on every modem, but mostly on the BG96. And most of the configuration that you would do on the BG96 to select different RAT types, for instance, okay, I want it to just work in GSM or CAT-M or narrowband, is using this Quectel prefixed configuration settings. So if you're working with this modem, this would be the commands that you would use the most. So you'd use this to set the RAT types to be searched, the search sequence, the network category, and this is particular to configuring just the Quectel modem itself. So I'd just like to take a minute to talk about scripting, because of course being able to write AT commands directly into the console is great. And it's a very quick way of checking that everything is working, but of course you don't want to be working on a terminal like this. This is not a solution that's going to work for devices in the field. So of course you're going to want to start scripting or building some application logic. So the control flow is very simple. You have some AT commands being sent to the device, and the modem is responding. So ideally what you want is something that looks like this, where I know that looks like there's a lot going on the left-hand side, but this is basically, you have a Python method that says, send this AT command over serial, wait for the response and tell me what it is. And then ultimately what your testing or your scripts would look like is something like on the right. So you'd have something that's readable, very short, and you say, okay, I want to scan for operators. I want to try and connect to networks that I'm interested in. And you want to automate or encapsulate all of the logic using scripts like this. So we can take a quick look at a Python library that does this. So I'll just close this screen session. Okay. So what I have in this directory is a couple of Python scripts that actually just automate this AT commands. So here we're using Python 3, and there's one to connect to Telefonica on cat-m. There's a -d flag, which means just printing out a lot of the communication that's between between the Raspberry Pi and the modem, just so that we can see which AT commands are being run at the time. Oops. I have to kill the screen process at the moment because that's still using the serial port. It's busy, but we can restart the Python script. So you can see this is going too fast to read, but essentially what's happening is we're automating a lot of the same processes that we did manually before, where we're sending AT commands to the device, checking what scene networks are, manually selecting this operator, trying to register, and importantly, like we see now where the script is pausing for a little bit, we're adding some back off to give the device time. So we can see it has registered, and now we're sending some data, and the script is done. So basically, what's happened there? Well, we have said we're only interested in one operator, Telefonica. We want to connect using this access technology, which is cat-m. And when we are roaming, then we want to send some data. So roughly on the left, you can see this is not the actual code, but that's roughly what we're doing. And you can see that this is very easy to set up in your own scripts using Python libraries. So I would say if you are doing this, you have to be careful with timing because, of course, any of these scripts are able to send a lot of commands to the modem very quickly. And the modems are quite fragile in terms of timing. So if you send a lot of, it's possible to send hundreds or thousands of commands to the modem in under a second, the modem will lock up because it's not, it requires timings in between the commands. So if you do something like we see here on the top, sending a lot of commands in under a second, the modem is going to lock and you'll have to restart the modem itself. So make sure that you have proper response times. Ideally, if your script to send an AT command would have some handling of timing in between commands automatically, so you don't have to write some sleeps everywhere. But that's just something to bear in mind. Quectel itself have one handy flow diagram on one of their specifications that shows exactly what to do in terms of the control flow, when to wait, when to restart the modem if it's locking up, and it gives you suggested timings in between and the suggested response times. So that's most of the demonstrations. One of the tips that I'd like to give is about the actual product specifications and the modem specs. So Quectel and the BG96, it unfortunately doesn't just have one AT command specification. We can take a look at the product details page. And just down at the very bottom here, if we click, oops, sorry, we see the AT commands manual. There's actually nine different PDFs. One is called AT commands manual. This is what you would imagine or assume that you would use as a reference, but it's quite possible that another feature that you're looking for, such as ping or TCP/IP commands, are in one of these other specifications. There's also a HTTPS manual, so this is something to look out for when you're looking through the modem specification. But these two AT commands and the TCP/IP commands are likely the ones that you'll be using. So we'll give you a We'll make the PowerPoint slides available afterwards, so you'll have these links available. And of course, the general reference is the Etsy spec. That's more like a standard set of AT commands, but like I mentioned, a lot of the proprietary commands are implemented by manufacturers, and it might be tricky you won't find everything inside the Etsy spec itself. You'll need to go to the device manufacturer for specifications. So we can take some time if anyone has any questions. You can feel free to write inside the questions box. Okay, we don't have any questions at the moment, but just wanted to point you also towards our knowledge base, where we have a very brief article that describes a command sequence for proper network connection and disconnection. We can make this link available afterwards, but you can see here we have from 1 to 10, 10 steps to get data connectivity using MFI SIMs. And this will get you up and running if you have a device that you need to use AT commands with. Okay, if there aren't any questions, then I'd like to conclude the webinar for today. So thanks to everyone for joining. I have one last thing to mention, and that's we have a upcoming webinar from Eric Roa, who's also an MFI customer success. So we have Nuestra API con Swagger, the MFI API with Swagger, and this is a Spanish language webinar. This is on Wednesday the 25th at 4 p.m. And we'll be covering the advantages of Swagger, which is a way of documenting REST APIs. We'll be covering how to use the MD5 documentation, and we'll have an interactive session because one of the main reasons of having Swagger itself is that you can make live HTTP requests of the documentation that it's describing. So this will be a very interesting one for our Spanish-speaking audience. So thank you very much. We'll make the slides and the presentation itself available afterwards. And I'd like to wish you a good day. All the best from Berlin. Thank you.